This is Activity 3, More Hanging Blocks, from Lesson 2, Keeping the Equation Balanced, and Unit 4, Linear Equations and Linear Systems. And this is a revised version of Activity 3. There are two balanced hangers in this activity, and you are told that the triangle weighs 3 grams. So this green triangle, these green triangles, all weigh 3 grams, and the red circles weigh 6 grams. So here are the circles, and they all weigh 6 grams. And you're supposed to find the weight of the square in hanger A and the weight of the pentagon in hanger B. Then you're supposed to write an equation that represents each hanger. Well, you can write an equation for hanger A right away. So there's 1x over here on the left side, and there's 5x's on the right side. There are 3 circles, so it's 3 times 6 plus 3 more with the 1 triangle. And on the right side, there's just 1 circle, so that weighs 6 grams. So an equation could be x plus 3 times 6. You can rewrite that as 18 plus 3 equals 5x plus 6. To figure out the weight of the square, take an equal amount from each side and keep the hanger balanced. So if I begin by taking 1 circle from each side, that's removing 6 grams. In the equation, that's removing 6 grams from the left, so now I only have 2 times 6, and this 6 grams from the right side. Continue to take away an equal amount from each side. So if I take away a square from each side, that's 1x removed from the left and 1x removed from the right. So this is now 2 times 6 is 12, plus 3 is 15, equals 4x. So we have 15 equals 4x. So we have 1 triangle, so this is going to be 3 grams for the triangle, and 2 circles. So this is 3 grams and 3 grams for 1 circle, and 3 grams and 3 grams for another circle. So now we have 5 equal parts, each weighing 3 grams, and we're going to divide those 5 parts among 4 squares, or 4 x's. I can take one of these 3 grams and give them to each of the x's. So 3 goes with this x, 3 grams goes with this x, 3 grams goes with this x, and 3 grams goes with this x. So that's 12 of the 15 grams I'm using up, and I have 3 grams left over. So give each of those x's 3 grams. So this answer is going to be that 3 grams plus a little bit more, because this is not quite 1 more gram that I can give to each of these x's. It's 3 grams now left over that I have to divide among each of these 4 x's. So there are the 3 grams. So imagine that you take these 3 grams and divide each one of them up into fourths, into 4 equal parts. That would give you a total of 12 fourths. Well, 12 things divided among 4 groups is going to be 3 of those fourths for each group. So this is going to be 3 3/4, 3 3/4, 3 3/4, and 3 3/4. So each group has 3 grams and 3/4 of a gram. So x is equal to 3 3/4. Here's the 3 right here, and here's the remaining amount that I divided up among the 4 x's. So this is 3/4 for each of those x's. So a total of 3 3/4 per x. For hanger B, I can write an equation right away. So I have 2 x's on the left side plus 2 times 6 on the left side. Then on the right side, I have 2 x's again plus 2 times 3 grams for each triangle plus 6 more grams for the circle. So 2x plus 2 times 6 equals 2x plus 2 times 3 plus 6. So now I want to take away an equal amount from each side. And if I do that by removing the pentagons, the 2 x's, from each side, I now have all of the x's removed. And so what's left is 12 is equal to 12. Well, that's true. So the equation is true. And what's interesting is that the pentagon can take any value because you're going to remove those. So whatever value I choose for the pentagons, it's equal on the left side and equal on the right side. You can remove those from the equation. So there is an infinite number of solutions for hanger B. The pentagon can have any value because the pentagons are balanced on each side.